a revolutionary telescope was launched into space, marking the beginning of a new era of scientific exploration.
The James Webb Telescope has done it again, and this time it's making headlines for something truly groundbreaking. Proxima B, the closest exoplanet to our solar system, might not be just another distant rock after all. Recent discoveries suggest that life could actually exist there, and the evidence is nothing short of jaw-dropping. What exactly did the James Webb Telescope find that's causing such a massive stir? Get ready as we dive into these groundbreaking revelations that could completely reshape our understanding of life beyond Earth. What's going on at Proxima B? The James Webb Telescope has detected something unusual on Proxima B, which is an exoplanet that has been of great interest since its discovery in 2016. But what makes Proxima B so special? And why are astronomers paying such close attention? First, the basics. Proxima Centauri B, also known as Alpha Centauri CB, is an exoplanet orbiting the red dwarf star Proxima Centauri, which is part of the Alpha Centauri triple star system and is the closest star to the Sun. Located about 4.2 light-years from Earth in the constellation Centaurus, it is one of the closest known exoplanets to our solar system, along with Proxima D and the disputed Proxima C. Proxima Centauri B orbits its star at a distance of approximately 7.264 million kilometers and completes one orbit in about 11.2 Earth days. That's pretty close in space terms. It orbits in what's known as the habitable zone around its star, Proxima Centauri. Now, the habitable zone is basically an area where conditions could allow for liquid water to exist, which is one of the key ingredients for life as we know it. So naturally, scientists have been eager to study this planet and see if it might hold any clues about the possibility of life beyond Earth. But the problem was that Proxima B orbits a red dwarf star, and red dwarfs are not exactly friendly neighbors. These stars are known for their violent behavior, often unleashing intense solar flares. This raises some serious concerns. A flare could easily strip away a planet's atmosphere, leaving it exposed and potentially uninhabitable. So even though Proxima B seemed promising, there were some big doubts about its ability to support life. And yet, despite these challenges, astronomers didn't give up. They kept studying the planet, hoping it might still reveal something important. While its characteristics are still not fully understood, it is believed to have a minimum mass of around 1.07 times that of Earth, with a radius only slightly larger than Earth's. The European Southern Observatory announced the discovery of Proxima Centauri B on the 24th of August 2016, following years of radial velocity studies of the parent star. This finding was significant because it marked the discovery of a planet in the habitable zone of the closest star to our solar system. The discovery generated interest in the Alpha Centauri system and raised the possibility of future robotic exploration, given the proximity of Proxima Centauri B to Earth. Although exoplanet searches had previously ruled out the existence of larger-than-Earth planets around Proxima Centauri, the discovery of Proxima B reignited interest in studying red dwarfs, as many of these stars are known to host planets, often in the habitable zone. Red dwarfs, the most common type of star, frequently have one or two planets. Before the discovery, observations at ESO's facilities in Chile revealed unexplained anomalies in Proxima Centauri, suggesting the presence of a planet. This led to the Pale Red Dot project in January 2016, which confirmed the existence of Proxima Centauri B later that year. In 2022, Proxima Centauri D, another planet closer to the star, was also confirmed, while the existence of Proxima Centauri C, reported in 2020, remains debated due to potential data artifacts. How similar is Proxima B to our Earth? When it comes to physical characteristics, Proxima B's mass is estimated to be about 1.07 to 1.17 times that of Earth, making it quite similar in size. However, its radius remains uncertain, with estimates ranging from 0.94 to 1.4 times Earth's radius. This variability in radius makes it difficult to definitively categorize the planet, and depending on its exact composition, it could be more Earth-like or potentially closer to a smaller Neptune-type planet. Proxima B's composition is still mostly speculative, But scientists suggest it could range from having a large core, similar to Mercury, to being a water-rich planet. Its formation likely differed from Earth, possibly involving stronger impacts and a faster overall development, which could have influenced its current makeup. One of the most significant factors affecting Proxima B is the likelihood that it is tidally locked to its star. This means that one side of the planet would always face Proxima Centauri, resulting in one hemisphere in permanent daylight and the other in perpetual darkness. Such a scenario would lead to extreme climate conditions, with only the twilight zone between the day and night sides potentially being habitable. However, there's still a possibility that Proxima B is not fully tidally locked, which could lead to more varied rotation patterns and different climate conditions. If the planet's orbit is slightly eccentric, it might follow a resonance similar to Mercury's, where its rotation and orbit create more dynamic conditions. In fact, new climate models, designed to simulate rocky exoplanets around red dwarfs, suggest that Proxima B could actually be habitable. Using a supercomputer, scientists created 3D simulations that revealed various potential climates based on environmental factors. When they simulated Proxima B's possible conditions, the results were surprising. Despite being tidally locked, with one side constantly exposed to heavy radiation, the planet might still support life. If Proxima B has an atmosphere similar to Earth's and a strong magnetic field, it could protect itself from the intense radiation emitted by its parent star. In this scenario, the planet might even be covered in an ocean stretching into its night side, possibly resembling a giant eyeball staring at its star. While that might sound strange, it's an exciting possibility for scientists looking for signs of life beyond Earth. For years, scientists have been eager to study this elusive part of the universe, hoping to uncover more details than ever before. Then came the game changer, the launch of the James Webb Space Telescope. One of its primary missions is to explore the cosmos with unparalleled clarity, pushing the boundaries of what we know. Unlike its famous predecessor, the Hubble, the James Webb is equipped with advanced infrared instruments, allowing it to peer deeper into space and time, capturing what Hubble couldn't. This upgrade opens up an entirely new frontier for scientific discovery. What has the James Webb Telescope found? When scientists pointed it toward Proxima B, they were hoping to gather more information about its atmosphere, surface, and maybe even signs of biological life. The interesting thing here is that instead of detecting the usual suspects like methane or water vapor, the telescope picked up something completely unexpected, a faint glow coming from the planet's night side. And no, this was not just some natural phenomenon like volcanic activity or auroras. This glow was steady and consistent, something that would more likely come from artificial lighting. You know, the kind of lights you would expect to see from a city at night. This discovery has left scientists shocked. Could this be evidence of an advanced civilization? While it is too early to jump to conclusions, the idea that we might have found signs of intelligent life is hard to ignore. After all, artificial lights are one of the few things we associate with developed civilizations, like seeing Earth from space. So if Proxima B really does have something similar going on, we might be looking at our first real clue that we are not alone in the universe. Now, what theories do scientists have for this new discovery? What does this mean? The discovery of potential artificial lights on Proxima B is nothing short of mind-blowing. If these lights really are a product of some advanced technology, it could mean that a highly developed civilization either exists or once existed on this nearby exoplanet. If that's true, this would be the first time we have found direct evidence of extraterrestrial technology. It is not a small discovery. It is not like we have found some bacteria or basic life forms. This could be intelligent beings, capable of shaping their environment, maybe even creating city-like structures. This is the kind of stuff that makes you sit up and realize just how big the universe really is. But as exciting as this all sounds, it leaves us with so many questions. If these lights are from a civilization, just how advanced are they? Are we talking about a society like ours, one that is experiencing its own technological developments and struggles, or is this something much more evolved? I mean, these lights cover a significant portion of the planet, according to the data from the James Webb Telescope. That could mean either one massive city or a bunch of smaller settlements scattered across the planet. Either way, we are talking about an organized society, not just random lights here and there. And then, of course, there is another question. How are these lights powered? Are they using something like electricity, as we do, generated from natural resources like coal, solar, or wind? Or, and here is where it gets really interesting, have they developed some advanced form of energy that we cannot even imagine yet? Proxima B orbits a red dwarf star, which is much cooler and dimmer than our Sun. This could mean the inhabitants had to get creative with their energy production. Maybe harnessing energy in ways that could give us clues about solving our own energy problems here on Earth. But what if these lights are just the remains of a civilization? Think about it. What if this is a society that once thrived but is now in decline? What could have caused it? Maybe they faced some internal conflict, ran into environmental issues, or even encountered some cosmic disaster. On the other hand, what if the civilization is still flourishing? If that's the case, it raises the possibility of actual contact between us and them. And the next thing we have to think about is whether we should even try to make contact. History tells us that when two civilizations meet, things don't always go smoothly. We have countless examples from our own history where encounters between human societies led to either cooperation or conflict. So if we do decide to reach out to this alien civilization, what would that look like? Do we approach them with caution, or do we jump right into it? The ethical and practical questions are endless, and honestly, a bit terrifying. There is also the big challenge this discovery presents to our current understanding of where life can exist. For the longest time, scientists thought that planets orbiting red dwarf stars were not exactly life-friendly. These stars often unleash powerful solar flares, which could easily wipe out an atmosphere and leave a planet barren. Yet, here we are, with potential evidence that not only life but intelligent life could be thriving in such conditions. If that's the case, it would completely change how we think about where life might exist in the universe. Red dwarfs are actually the most common type of star in our galaxy, and if life can thrive on Proxima B, that means there could be many other planets around red dwarfs where life could also exist. Suddenly, the universe is looking a lot more crowded. Even the places we once thought were unlikely candidates for life might need a second look. So, what's next? How does this discovery affect space exploration? What this discovery means for us? This discovery could be a game-changer for space exploration. The fact that Proxima B is relatively close to Earth in astronomical terms makes it a prime target for future missions. It is just 4.24 light-years away. Sure, that distance is still mind-boggling by our human standards, but in the grand scheme of the universe, it is practically in our backyard. Over the years, there's been a growing rumor around the idea of sending probes or even crewed missions to nearby star systems. Now, with the possibility of city lights on Proxima B, things could speed up big time. Scientists could develop advanced propulsion technologies so that we can study Proxima B and its possible inhabitants up close. It is not as far-fetched as it used to sound. The discovery of potential artificial lights there makes it an even more exciting candidate for future exploration. The goal would be to gather more data, get up close and personal with the planet, and maybe even discover if we are really dealing with an intelligent civilization out there. This is not the first time we have tried to find extraterrestrial life. We already have an institute called SETI, which stands for Search for Extraterrestrial Intelligence. Traditionally, SETI has focused on trying to detect radio signals or other forms of communication from distant civilizations. But with this new discovery, we might need to switch things up. The idea of finding city lights rather than listening for signals suggests that we should be on the lookout for other signs of advanced technology. Think about it. What if there are more planets out there like Proxima B, where artificial lighting or even massive structures could indicate life? This could mark the beginning of a whole new era in the search for extraterrestrial intelligence. But it is not just the scientists who are getting excited. This discovery has captured the public's imagination like few space-related events have in recent years. The idea that an alien civilization might be close enough for us to see the lights of its cities is both thrilling and awe-inspiring. People are excited about this discovery. They have been following every update from the James Webb Telescope and eagerly waiting to see what comes next. And honestly, who could blame them? Beyond the science and public fascination, there is also something bigger to think about. The potential discovery of an intelligent civilization challenges us to reconsider our place in the universe. We have always seen ourselves as the top species, the pinnacle of evolution. But if Proxima B really does have intelligent life, we are not alone. This realization might change how we see ourselves and our responsibilities as a species, both to our planet and to the technology we create. It is a lot to think about, but it could push humanity in exciting new directions. And not just that, we might also be looking at some threats. How can we prepare ourselves if an alien race does exist just some light-years kilometers away? Potential threats. The possibility of an advanced civilization on Proxima B raises many questions and concerns. If these lights detected on the planet are truly artificial, we are looking at a society that has mastered some impressive technological feats. But what can we learn from them? Could they show us how to build a sustainable, advanced society? Or on the other hand, warn us of the dangers that come with rapid technological progress? There is also the unsettling thought, would they see us as a potential threat? Just as we might be cautious about them, they could be equally wary of Earth. The prospect of making contact with an alien civilization brings up difficult questions about our future, our place in the universe, and how we handle the responsibility of advancing technology. Plus, it forces us to consider what kind of civilization we are or want to become as we explore the cosmos. One thing is for sure, if these lights are real, they could be the catalyst for some serious international cooperation. Studying a planet that's light years away is not a job for just one country. It is going to require the kind of teamwork we have seen with projects like the International Space Station. Many countries would have to come together, pool resources, and share knowledge, all for the common goal of exploring Proxima B and potentially making contact. This could inspire a new wave of collaboration in space exploration. Now, if there really is a civilization on Proxima B, one of the first questions we would probably ask is how they have managed to survive in such a hostile environment. Remember, Proxima B is orbiting a red dwarf star, Proxima Centauri, which is notorious for its intense stellar flares. These flares can bombard the planet with harmful radiation, making it hard to imagine life surviving there. But if these lights are anything to go by, it suggests that the inhabitants of Proxima B have found some way to protect themselves. Maybe they have developed advanced technology to control their atmosphere or shield their cities from radiation. They might have even adapted biologically or technologically to thrive under such extreme conditions. That would give us a whole new understanding of how life can evolve in ways we have never thought possible. And let's not forget about the lights themselves. What if the technology powering them is something far beyond our current understanding? We are talking about the possibility of energy sources we cannot even conceive yet. Antimatter reactors, zero-point energy, or harnessing the energy of their star in ways we have only dreamed of. The intensity and spread of these lights could offer some serious clues about the level of technology this civilization has achieved. If they have tapped into energy sources that are far beyond anything we have come up with, it could totally redefine what we think is possible for our own future. There is also a fascinating cultural angle to consider. The distribution of these lights across the planet could give us a peek into society's structure. Are the lights spread evenly? If so, it would suggest there is a highly connected global society. But what if the light is clustered in certain areas? Then it would hint at the existence of city-states, nations, or factions. The patterns could reveal a lot about how this alien civilization functions, from urban planning to technological priorities. Understanding how this alien society operates would be important if we ever do make contact. Are they peaceful explorers, eager to share their knowledge and culture? Or are they isolationists, choosing to remain hidden from the rest of the universe? Their lights suggest a civilization that is advanced enough to possibly engage in interstellar travel. If that's the case, they could have already explored other planets and star systems beyond Proxima Centauri. Another question that keeps popping up is the timing of this discovery. Proxima B is only 4.24 light-years away, which means the light we are seeing now left the planet just over 4 years ago. That's almost real time in the grand scheme of space. This raises the possibility that any civilization on Proxima B could be at a similar technological stage as us right now. They could be facing the same societal challenges or working on the same advancements, but in an alien world. Alternatively, they might be a much older civilization that's already hit its technological peak or even collapsed, with the lights being the last remnants of a once great society. The sheer proximity of Proxima B means that communication, while challenging, would not take as long as we might expect. The possibilities of making contact with an alien civilization on Proxima B are staggering. If we send a signal out, we can receive a response in just 9 years. That's the potential here. While Proxima B remains a promising candidate for extraterrestrial life, it is far from the only place in our galaxy, or even in our solar system, where we might find signs of life. What do we know about alien life on other planets? NASA's exoplanet program is on a mission to discover unmistakable signs of life on other worlds, and we've already taken crucial steps towards that goal with telescopes like the James Webb and the upcoming Nancy Grace Roman Space Telescope. These advanced tools are designed to analyze planets for signs like oxygen, water vapor, and other indicators that suggest a planet could harbor life. But the search for life isn't limited to distant exoplanets. Right here in our own solar system, there are several intriguing candidates. For years, scientists believed that Earth was the only habitable place, as planets like Mars seemed too dry and cold, and Venus too hot. However, recent discoveries have changed that perspective, showing that life can thrive in extreme environments, and that some of our closest neighbors might be harboring life beneath their surfaces. But the hunt for life isn't confined to distant exoplanets. Right here in our own solar system, the prospects of finding life have expanded dramatically in recent years. Early assumptions painted the solar system as largely barren, with Venus deemed too hot, Mars too cold and dry, and gas giants like Jupiter and Saturn uninhabitable. However, we've come to learn that life can thrive in extreme environments, and our rocky neighbors may harbor conditions suitable for life, at least in some form. Mars, of course, has always been a favorite in the search for life. Billions of years ago, Mars had lakes and rivers, and even today, there's evidence of liquid water beneath its surface. NASA's Perseverance rover is scouring the planet for signs of ancient microbial life, and radar studies suggest that reservoirs of water might still exist underground, offering potential habitats for life. Venus, long considered inhospitable, has recently come back into the spotlight after scientists detected phosphine gas in its atmosphere. On Earth, this gas is typically produced by microbes in oxygen-poor environments, leading to speculation that similar processes could be happening in the clouds of Venus. While the idea of life thriving in such a harsh atmosphere seems far-fetched, it has spurred renewed interest in exploring our fiery neighbor. Beyond the inner planets, the moons of Jupiter and Saturn offer some of the most compelling environments for life. Europa, one of Jupiter's moons, is covered in an icy shell, beneath which lies a vast ocean heated by tidal forces. This subsurface ocean could be rich with the elements necessary for life. Similarly, Saturn's moon Enceladus has geysers that spew water vapor and organic compounds into space, pointing to a salty ocean beneath its icy surface. Both of these moons are high on the list for future missions, with NASA planning to send the Europa Clipper to study Europa's potential habitability. Even Neptune's moon Triton and the dwarf planet Ceres show some potential. Triton, with its nitrogen geysers and icy crust, could harbor subsurface oceans warmed by tidal forces, while Ceres may also have a deep, salty ocean beneath its surface. Although the conditions on these distant worlds are far more extreme, life has proven to be adaptable, surviving in places on Earth that we once thought impossible. But there are a lot more solar systems out there to explore, and researchers have recently discovered what they're calling the perfect solar system. The perfect solar system. It is a rare planetary system located 100 light-years away from Earth. Unlike our own solar system, which formed through violent collisions that left us with planets of varying sizes, this newly discovered system, HD 110067, is remarkably orderly. All 6 planets are almost identical in size and have remained undisturbed for up to 12 billion years. These conditions provide a unique opportunity to study how planets form and evolve, possibly offering clues to whether they can support life. In our solar system, planets like Earth, Jupiter, and Saturn were formed through chaotic processes, resulting in wildly different sizes and characteristics. However, in the HD 110067 system, the planets have maintained a uniformity not seen before. They also follow a synchronized orbital pattern, rotating in a precise rhythm that allows researchers to liken the system's movement to a musical composition. For example, the innermost planet completes 3 orbits in the time the next planet completes 2, creating a perfect planetary choreography. Dr. Raphael Luke from the University of Chicago described the system as ideal for studying planetary formation due to its stability, while Dr. Marina Lafarga Magro from Warwick University called it beautiful and unique. What excites researchers even more is the brightness of the star, which makes it easier to study the planet's atmospheres in the search for life. The 6 planets in the system are categorized as sub-Neptunes, meaning they are larger than Earth but smaller than Neptune. Despite the growing interest in sub-Neptunes, much remains unknown about these planets, such as their composition and whether they can sustain life. The discovery of HD 110067 offers an unparalleled chance to study these common yet enigmatic planets in detail. Recent interest in sub-Neptunes has surged after scientists detected signs of potential life on K218b, another sub-Neptune, where hints of a gas associated with life were found in its atmosphere. With sub-Neptunes believed to be the most common type of planet in the galaxy, the HD 110067 system presents an extraordinary opportunity to uncover more about their potential habitability. NASA's Transiting Exoplanet Survey Satellite and ESA's Characterizing Exoplanet Satellite, CHEOPS, were instrumental in detecting these planets. With advances in telescope technology, astronomers are optimistic that they may soon find biosignatures, chemical indications of life, on one of the planets in this perfect system. If researchers confirm that sub-Neptunes can support life, it would vastly increase the number of planets where we could find extraterrestrial life. Dr. Luke believes that within the next decade, we might get definitive answers, marking a major step forward in the search for life beyond Earth. What does the future hold? For the first time ever, humanity could be on the verge of engaging in a real-time conversation with another intelligent species. The idea is thrilling, but the logistics are a whole different ballgame. What language would we use? How would we even ensure we're understanding each other correctly? These are huge challenges, but the short communication delay with Proxima B makes it more feasible than ever before. And then there's their technology. We've already spotted possible city lights, but what other signals or technologies could be hiding there, undetected? This could be just the beginning. Imagine the possibility of them having massive engineering projects, producing gravitational waves, or something equally mind-blowing. Every new discovery could unlock deeper insights into their technological prowess. And who knows, it might even serve as a roadmap for our own future development. The big question remains, though, who or what actually lives on Proxima B? If this civilization is advanced enough to produce artificial lighting, we can probably assume they're intelligent beings. But their biology, that's a whole different story. Proxima B orbits a red dwarf star, which means the conditions are extreme. The life forms there could have evolved with totally unique biological features to survive the planet's volatile environment. Or maybe they've gone beyond biology as we know it. Perhaps they've merged with technology to become a post-biological society where machines and organic life coexist to create something entirely new. This raises an interesting question about intelligence. For centuries, we've only understood intelligence through our own human lens. But what if the life forms on Proxima B have developed intelligence in ways we can't even comprehend yet? Maybe they operate on a collective consciousness or something entirely unfamiliar to us. It could reshape how we define intelligence and even influence how we think about AI and machine learning here on Earth. And if we go even bigger, the thought of cultural exchange is mind-blowing. Imagine the knowledge, ideas, and innovations that could come from interacting with an entirely different species. We could learn about new forms of governance, philosophy, art, and science, concepts that have evolved under completely different circumstances. Such collaboration could spark a creative renaissance for both species. This potential for mutual enlightenment and cultural enrichment underscores the unprecedented opportunities that lie ahead. By forging a connection with Proxima B, we could enter a new era of interstellar cooperation and shared wisdom, paving the way for a future rich with collective advancements and a broader understanding of the universe. All right, so that's it for this video. And if you want to watch more amazing content like this, check out some of our other videos. Bye.